Okay, we're gonna kind of try to keep this going, because guys, it isn't on a Friday, and I don't wanna keep you guys here all day. And, you know, but we're gonna try to go through it, but let's not shorten it either. I mean, if you got questions, I'll be around when this is done and we can talk, you know, whatever, but I wanna try to keep it going because there is a lot of material here I'm trying to cram into. I'll just go ahead and say it. What I'm doing today, normally we would do in a 1.5, 2-day session. Now, granted, we do hands-on with that one, and it's kind of hard to take a hands-on show on the road. I'm working on trying to figure out how to do it, but it's the stuff that we do is just it's too difficult. So we have to do it this way. This is a cross section of our solenoid valve types, just to give you an idea. You may or may not be familiar with these. Our basic is our EVRA. Okay, that's just an ammonia solenoid valve. We have an EVRAT, which is nothing more than an EVRA with assisted lift. So in there on the armature above the diaphragm is going to be a spring, and that spring is going to be assisted lift, so it's going to help the valve to open. Okay. Then ICS solenoid, we will talk about ICS valve later, but just to say that's an ICS control valve just set up as a simple solenoid valve. I think it's done a lot just for industrial applications where they don't want to use a solenoid valve and they want something big. So they can get a large ICS valve like that and just make it a solenoid. So it's a valve that could be a regulator, but it's not, because all they did is put a solenoid on it and boom, it closes, it opens. You know, energize, open, de-energize, close. So we have that. PM valve was a solenoid valve. It's gone now. We don't have the PM. Everything is now ICS valves, which is different types of regulators. I'll spend a good bit of time on that. And then a very special classification of a solenoid is our new ICSH. That's a 2-step hot gas valve, or what we call a soft gas valve. We'll talk about that as well. Okay, so basic EVRA and EVRT. Okay, it's flanged ductile iron body. It does have external strainers, and they can be close coupled to the valves with that FA, but again, I said we're kind of moving away from that and going to the ICF valve station. They have surface treatment. Teflon seat is standard, and the stainless steel bolts. This is the cross section of what one looks like. We have 2 types. We have direct operated, so here doesn't need any pressure differential to activate the valve. Okay, it basically opens when the armature energizes and pulls up. It opens the valve. It's that, and that's the case with our small ones. It's got a Teflon valve plate. Excuse me. And when de-energized, the inlet pressure, the spring force, and the weight of the armature is what actually closes the valve. You can see a cross section of that. Then you've got the EVRA 10, 15, and 20. Okay, these valves need pressure differential for them to actually actuate. Okay, so it needs to see a differential across the valve for that thing too. That you can energize it, but if there's no pressure differential, the valve's not going to actuate. Okay. And here's you energize the coil, that pilot orifice is what opens, and basically the pressure differential between the inlet and the outlet then forces the valve open. Okay. And here's your assisted lift, so you can see on the armature that there's a little spring down there. No pressure differential required for the EVRAT. And the strainer, we've already talked about this. I told you we'd go across this. Now this is a piston design and is servo operated. So you can see the coil is off to the side, okay? So that pilot is what actually, when you energize, the pressure differential is what actuates that piston and opens the valve. This particular one, this 1-inch size, it requires a little bit more differential. As the valves go up in size, they typically require a little bit more differential to actuate. And The large ones, actually, I didn't point it out on the other 10, 15, and 20. They do have a manual stem. You guys familiar with manual stems on valves, the manual operators? It's gonna be pretty much standard across our product line. Solenoids, ICS, ICLX, solenoids on the ICF valve station, so there's and it's a large variety, so we'll kind of try to cover them as we go. In general, almost every product we have, with the exception of 2, it goes like you would think it would go. Turn the stem clockwise in to put it in manual operation, to manually open the valve. Turn it counterclockwise all the way out for it to work, the valve to work automatically. There's 2 exceptions. I'll go ahead and tell them to you right now. One of them is the ICLX special gas-powered suction stop valve. There's a reason why it's that way. It's actually backwards. Clockwise basically puts it in auto, counterclockwise puts it in manual. So it's that one, and it's this one right here on our ICF valve station. And you can tell which one it is because the solenoid pilot is off to the side. It's not in the center like a normal solenoid. So when you see that right there is going to be different. You're going to turn it counterclockwise to put it in manual, and clockwise to put it in auto. It can get confusing. So here we'll talk about ICS valves, but they're regular valves, but you can turn them into solenoid valves. I won't spend any time on this because we're going to talk about them later. But just to show you, this is what it looks like. You got a body, you got a function module, and you got a cover with a pilot in the cover, a pilot hole in the cover, and then you're going to put an EVM solenoid pilot that I talked about, and you turn that into, with a coil on there, you turn that into a solenoid valve. Okay, the last one here for this group is a soft or safe, we call it, in Europe they call it safe hot gas, we call it soft start here. So this valve is intended in hot gas supply for defrost. Essentially what it does is it enables you to, when you go into hot gas defrost, it enables you to start soft. So it opens about 20%. And there's a way that it does that. You have to energize these coils separately. Okay, so S1 would be energized first, you get about 20%. And then S2 coil would be energized and you get 100%. It's pretty straightforward.
So you're saying you can't use that in a liquid application? A lot of times in the solenoids, you got hammering and stuff, so you might, and I used it, matter of fact, this plant, I did a 2-step valve. I mean, you're just calling it out for hot gas.
It is just for hot gas, yeah. Honestly, that's a good question. I don't know if it's ever been used for liquid feed or not. That's actually a really good question. I hadn't thought about that.
I mean, do you have anything that opens soft for liquid?
No.
Or that steps for liquid?
No. Not that I'm aware of.
I can't imagine that would not work.
Yeah, I can't think of a reason actually why it wouldn't. It's just intended.
It just may not be rated.
I'm actually gonna, that's interesting. No, I can't think of a reason why it wouldn't be.
It works. Well, not with Danfoss.
He's not using a Danfoss valve. That's a good question. I like that. I'm
getting ready to do it again.
So the ICSH is a part of what we call the ICV valve, which envelops the whole, the ICS, the ICLX, all the control regulating valves. And this just shows you how it breaks down, how it works. You've got a body, you've got some type of function module for that specific application, and then above that you've got the control. So it's either going to be a pilot, it's going to be a motor actuator, or it's going to be a set of solenoids. And everything we have is like this. This is how it's broken down. And then the ICSH is a special part of that. Okay, it builds that soft start. I'm guessing though, it's probably going to work with liquid. I can't imagine that it would.
You got any flyers or any information on it?
It's all online now these days. Everything's online. Yeah. Do you work with industrial refrigeration parts. I mean,
Sometimes.
they should be able to get you, I mean, they should be able to lead you to it anyway, it's pretty easy to get, yeah. Okay, and then you got the function module in the body. And then the operation of the ICSH, I've really already covered it. It's in 2 steps, but for step 1, you know, it's S1. For step 2, it's S2. Okay, you can put this into. It comes standard in configuration 1. You can put this thing in configuration 2, where it actually turns it into a single step. Not a single step, excuse me, that's ICLX, I'm getting confused, I'm sorry. An independent, okay? So, step 1 can happen or not happen, and then step 2 can be engaged. If you've got it in this first configuration, which is what ours is standard from the factory, it has to do step 1, 20%, before it will allow step 2 to be engaged, okay? In that configuration, that's standard from the factory. So just know that you can change it. It's fairly easy to do. And this is a lot of detail here, and I'm just going to put it really simply for you. So that S1 has that pilot. Well, we call it an EVM pilot, solenoid pilot, where it feeds into the chamber where the piston is. This is the piston. So the top of that looks like, what did I do? I guess I passed it around again. I seem to be passing stuff around when I shouldn't be passing it around. Okay, so the function module, the top of it, what happens is there's a protrusion, a pin with a hole in the middle of it. And so when it feeds and that piston goes down, okay, as the flow increases, that pin actually gets closed off, okay, and so then the valve closes it off, and then it basically opens it back up. So this thing's just sitting there floating on that pin that's sticking into the chamber there, and it hits 20%. Is really what it does. How it gets the 100% is it has on S2, it has another passage that comes directly down on top of this, okay? And then it just opens the valve 100% when that hits. That's just a simple version of it. Coils, I'm not going to talk about coils a whole lot, just so we've got, you know, AC and DC. These, it says it easily mounts and comes off. Actually, with a screwdriver, it easily mounts and comes off. Yeah, if I pop that down, there's a recess in there, and you can see on top of these solenoids that, you know, that little ring there, and when it pops on, you got a screwdriver to pop it off. But it's on there snug. It's not going to fall off. It's not going to pull off. So that's just a feature we have on ours. We have different electrical connections. We've got conduit. We've got junction. We've got junction box. We've got DIN connector, and we've got terminal box. The terminal box here down at the bottom is what I have, and it's the most common. And so that terminal box screws off. You make your wire connections, and then you just screw that back on. That's the most common one. It also comes with a light, a green light that's there, so that when it's energized, the green light's on. You may see that, it's out there. The cheapest, of course, the cheapest version would be this junction box here. And the center one is not, I don't see that a lot of industrial refrigeration. Oh, and I didn't say it, but it's that one is NEMA 6. That's why it's probably the most popular. I think that's why we see it the most. And so here's the terminal box, and shows you how it comes off. That piece comes off. You make your wire connections, and then when you put it back on, it makes the electrical connection to the coil.